You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Good morning, everybody. My name is Bob Keane. I'm the editor of the journal Fire Ecology, an international journal that celebrates the ecology of fire. Today, in our podcast, we have three great guests and a very, very important paper that we'd like to discuss. The paper is Fire Severity Influences Large Wood and Stream Ecosystem Responses in Western Oregon Watersheds. And with me, we have Ashley Coble, Brooke Penaluna, and Lauren Six. So I'd like each one of you to introduce yourselves. Ashley, why don't you go first?
Great, thank you. My name is Ashley Coble, and I am a senior scientist with the National Council for Air and Stream Improvement, or NCASI, and I'm based in Corvallis, Oregon.
Brooke?
Hi, everybody. I'm Brooke Penaluna, and I'm a research fish biologist with the Pacific Northwest Research Station, which is the research branch of the Forest Service, and I am also located in Corvallis, Oregon.
And Laura?
Yeah, hi, my name is Laura Six. I'm a forest ecologist at Weyerhaeuser Company, and I'm based in Centralia, Washington.
Well, welcome, you three, and I really appreciate the time that you're taking to come and do the podcast with us and talk about this very important topic. So, Ashley, why don't you give us the elevator speech about this paper? What's it all about?
So we were really interested in in-stream large wood and how that varied with wildfire because in-stream large wood is such an important component of aquatic ecosystems. Some of its functions include that it provides refugia for fish and amphibians. It can affect channel geomorphology as well as flow conditions and velocity. It can generate pools, and also as a function of those changes can then allow for increases in sediment as well as organic matter storage in the channel. So collectively, any increase in large wood can also ultimately affect macroinvertebrate as well as fish populations in our aquatic food webs. And so we expected to observe greater large wood volume as well as sediment storage in the more severely burned watersheds within the first summer after these wildfires. But what we found is that large wood diameter was actually smaller in the more severely burned watersheds. But we did not find any differences in large wood volume, length, or even position within the channel itself as a function of fire severity. We also didn't see any changes in terms of sediment storage with fire severity in this first summer after the wildfires. And so we attribute this likely to generally a lack of storm events or high intensity precipitation events that occurred within that first winter between the fires and the timing of our sampling. We did compare our large wood diameter in the streams with the large wood diameter of coarse wood in our riparian areas. And we found that that diameter is larger in the riparian areas in the majority of our sites. And so that suggests that there is still some potential future recruitment of large diameter wood into streams from some of these riparian zones in the most severely burned watersheds. And so future high flow events have the potential to deliver that wood to our stream channels.
Wow, I thought the paper was very interesting in that it looked at both riparian and aquatic responses, which is very unique. So I'll ask the three of you, why did you write this paper? What was it that compelled you to write it?
So the Labor Day fires occurred in 2020. They were either ignited or spread on Labor Day, hence the name Labor Day fires. These included multiple simultaneous mega fires that occurred in Oregon's Western Cascades. And there are other fires in Oregon as well, but we were particularly interested in this set of fires because they burned forested watersheds that spanned ownership boundaries. And so we saw this as a unique opportunity to design a study to not only evaluate the immediate aquatic and riparian ecosystem responses to wildfire, but also to incorporate watersheds that drain both public and private forest land. And so we specifically designed our study to encompass not only the range of fire severity, but also to incorporate pre-fire stand age, which allowed us to have a proxy of both ownership and the differing forest management practices that occur. So in this paper, we primarily explore the relationships of pre-fire stand age and fire severity on large wood, but we also assess the relationship of large wood to many of the other responses in the stream as well as in the riparian zone.
So as Ashley said, it was important to us that we understand the range of aquatic responses to fire across land ownership boundaries, because oftentimes studies are only done in one type of ownership. So we have several ownerships represented in our 24 study sites across private lands, state lands, and federal lands. And often, as in the case of the Cascade Mountain Range, the different ownerships vary in the pre-fire management as well as post-fire management. In addition, they vary in elevation, which affects precipitation and temperature.
And you alluded to it earlier, but this was also a really good opportunity, and I think it's very important to link both the aquatic to the terrestrial dynamics, more fully understand the impacts of fire in the riparian areas.
Yeah, that's great. So let's talk about the results. What did you find out about the broad riparian responses?
Yeah, so in the riparian areas before the fire, they were similar in their proportion of deciduous and conifer trees, a similar makeup, but we found that we had higher mortality rates in burned riparian areas. That's not a surprise. So we had mortality after fire. But what was interesting is that we found much higher mortality of trees like western red cedar, while deciduous trees like red alder had lower mortality rates, like 6 times lower mortality rates than western red cedar. We also found smaller diameter wood in the riparian areas and in the streams after that high severity fire, which we think is likely from the higher mortality of small trees. And then that obviously links over to the aquatic variables.
And Brooke, what about the broad aquatic responses?
Yeah, so more generally, we found that fire severity exerted strong control on the stream responses. Again, our study was across 24 watersheds and multiple large fires in Western Oregon. And so that explained more of the variation in the aquatic ecosystem responses than did pre-fire stand age. We found that at higher fire severities, that various responses were higher were riparian tree mortality, light, and DOM concentrations, canopy cover, large wood diameter, and macroinvertebrate diversity, as well as fish densities were lower. So macroinvertebrates, which are secondary producers, responded to fire severity, exhibiting an increase in density, but a decrease in diversity, scrapers, and intolerant and sensitive taxa in more of the severely burned watersheds. Specific to fish, we found that fish density and biomass density was lower in more severely burned watersheds. So there was a drop, but because we are measuring these effects over time, we're going to be able to understand how long those patterns persist and when they change.
That's great. What do you think the implications of this are? And I'll ask that of all three of you. Go ahead.
Sure. So just to reiterate, this paper reported really on the initial response post-fire. So we think of this as a little bit of a baseline response. We are continuing to monitor these aquatic and riparian ecosystems across all 24 watersheds. And we think that ultimately these data are going to be really important in understanding the long-term effects of post-fire salvage logging on aquatic ecosystems. And ultimately, that's going to affect largewood recruitment to streams for decades.
Yeah, and following on what Ashley said, the management of forests following fires differs with landowner objectives, which leads to different trajectories of stream ecosystem recovery, warranting continued monitoring of responses beyond a year post-fire to understand their recovery over time. For example, how do responses of macroinvertebrates, fish, and largewood recruitment change over time? How will recovery differ across gradients of fire severity and pre-fire forest management intensity? And future largewood recruitment may occur as dead standing trees fall and large precipitation events deliver this riparian coarse wood to streams.
And I think it's also important to note for land managers and other folks interested that red alder seems to have a pretty important function in these burn riparian zones. It shows some resiliency to fire, which may provide root strength and bank stability and maybe even facilitate a more rapid recovery for these streams in these fire-prone landscapes. So that suggests some management implications here to maintain overstory species diversity in these riparian areas.
Well, this has been a very interesting podcast and a very important study. And I want to thank all three of you for joining me. It's been a great time. I really learned a lot. Ashley, I want to know if you want to recognize any funding that was used to do this study.
Sure. So this research was funded by Ecology as well as by Weyerhaeuser Company.
Wonderful. Thank you again, you three. And thank you, listeners, for tuning in to another episode of Fire Ecology Chats. And please go out and get this paper. It's well worth it. Thank you, everyone.